This is a super big deal. Like my prediction is that, on this front, is that Optimus will be the biggest product of all time by far. Nothing will even be close. I think it'll be 10 times bigger than the next biggest product ever made.
This is everything we know so far about Tesla's humanoid robot, and where the technology is realistically headed next. Optimus stands 5'8" and weighs roughly 160 pounds. It's a true general-purpose humanoid, built not for one specific job, but to operate in human spaces, handle the tasks we do, and eventually learn new ones on its own. And if Tesla succeeds, this won't just be another robot. It'll be the beginning of physical AI at human scale. Every version so far, from the slow, careful prototype shown in 2022 to the much more refined Optimus Gen 2, has been focused on the same goal: to move with balance, manipulate real objects, and eventually think and adapt almost the way a human does. Today, Optimus can walk, balance, climb stairs, handle fragile objects like eggs, sort items, fold towels, and perform basic repetitive tasks. Some of these demonstrations were guided by human teleoperation, while others ran on real onboard AI. Some audiences were disappointed to learn that humans were assisting behind the scenes in those early demos, but that's actually how robotics works. Every major breakthrough starts with human-guided training long before full autonomy takes over. Tesla built almost every critical part of Optimus in-house, including the actuators, the motors, the gearing, the sensors, and even the AI and network infrastructure that coordinates all of it. And if you're curious what that really means under the hood, this is where the engineering gets interesting. Optimus uses Tesla's own custom-built actuators, basically compact, high-torque electric motors paired with precision planetary gear sets. They're made from the same engineering DNA Tesla uses in its vehicle motors, just miniaturized and redesigned for joint-level control. Each actuator contains a rotor, stator, reduction gears, encoders for position tracking, and force sensors that tell the robot how hard it's pulling or gripping at any moment. These aren't hobby motors. These are industrial-grade, torque-dense actuators built to behave like artificial muscles, fast when they need to be, strong when they have to be, and efficient enough to run for hours without burning through the battery. Every joint, shoulders, elbows, wrists, hips, knees, and ankles, uses a different size actuator built specifically for that joint's torque profile. Optimus has roughly 28 to 40 points of movement, powered by high-torque motors, fingertip pressure sensors, multi-axis force sensing, and a 2.3 kilowatt-hour battery that drives the entire system. And for a robot its size, it's surprisingly strong. It can carry about 45 pounds while walking and deadlift close to 150 pounds. To visualize that, carrying 45 pounds is like walking through your living room holding one of those heavy 5-gallon water refill jugs, steady and without losing balance. And a 150-pound deadlift is roughly the weight of a washer and dryer stacked together. Imagine lifting both at once if they were bolted as a single unit. For a humanoid robot, that level of strength and stability is remarkable. At rest, Optimus only uses about 100 watts of power. That's roughly the same as a bright household light bulb. When it's moving at full speed, it uses around 500 watts, about the same as a small space heater or a high-end gaming PC. For a full-size humanoid robot, that's extremely efficient, and it's one of the reasons Tesla believes they can produce these at scale. Think the real magic is the hardware. The software is just as powerful, and the two work together seamlessly. It's a true marriage between both worlds. Optimus uses Tesla's end-to-end neural network, the exact same brain architecture behind full self-driving. It watches the world through its cameras, feeds that video into a vision transformer that understands what's happening, and then picks the right action directly from that video feed. This is why the robot can learn tasks instead of being manually programmed. Tesla trains Optimus using a combination of methods that almost mirrors how you'd teach a human, just with far more precision. With motion capture, people perform tasks while the robot studies those movements frame by frame. Through teleoperation, engineers guide its hands and steps directly, as if controlling a highly advanced remote puppet, showing Optimus exactly how a task should feel. And inside massive simulated worlds, the robot runs through millions of trial and error attempts, learning through reinforcement until it can perform those tasks on its own. But here's the powerful part. Every Optimus Tesla builds become another source of experience. Each robot sends what it learns back into one central intelligence loop, the same kind of data flywheel that millions of Tesla vehicles use to constantly improve full self-driving. The more robots Tesla deploys, the smarter the entire system becomes. Every new Optimus feeds more data into the loop, accelerating its intelligence. That's why NVIDIA's CEO said Optimus could be the first humanoid robot to truly scale. Tesla's first deployment of Optimus will happen inside its own factories, sorting parts, moving materials, and taking over repetitive workflows. This isn't hypothetical anymore. Tesla has already built pilot production lines in Fremont, and early batches of Optimus units are being assembled and tested directly on real factory tasks. Nothing about this is theoretical anymore. Tesla already has dedicated production lines for humanoid robots, and they're built the same way their vehicle lines are, designed for scale. Multiple stations assembling arms, hands, legs and torsos in continuous flow. As the system expands, robots won't be built one at a time, but steadily, almost rhythmically, the same way Tesla produces car components today. And this is where it gets interesting. AI-driven factories will play a major role. Automated inspection, robotic assembly, and AI scheduling will allow robots to help build more robots. With Generation 3 expected in 2026, Tesla isn't just creating a new product. They're building the manufacturing engine that could produce these machines by the thousands. But here's the truth most people never hear. Optimus still struggles with dexterity. Its hands aren't as strong or as precise as ours. Actuators can overheat, joints can fail, and fully unsupervised autonomy, the point where a robot can truly handle everything on its own, isn't here yet. To picture the challenge, imagine something as simple as picking up a set of car keys from a cluttered counter. For us, that's effortless. For a robot, that one task requires perfect balance, accurate vision, fingertip pressure control, and constant micro-adjustments in grip. On my difficulty scale, that's a 7 out of 10, just to lift a pair of keys. This is why most humanoid robots, not just Teslas, look flawless in demos, but struggle in the unpredictable real world. Scaling a machine this complex into thousands of reliable, everyday units is one of the hardest engineering problems on Earth. But it's not impossible, and that's exactly why the next generation matters. Now let's talk realistic possibilities, not hype. If Tesla pulls this off, Optimus could work 24 hours a day, help aging populations, assist in hospitals, operate in warehouses, maintain homes, and eventually handle basic household tasks. Will it one day drive a Tesla, go to the store, pick up groceries, come home and cook a meal? I don't know. Tesla hasn't promised that exact future. But if you combine self-driving cars with a capable humanoid that can safely move, see and use its hands, some version of that world doesn't feel impossible. It's not where Optimus is today, but it's the kind of scenario that shows why Tesla is pushing so hard to make physical AI real. Driving itself may not even be necessary. Tesla's robo-taxis will likely handle the transportation. But an Optimus with solid mobility and reliable hands could handle the rest. It could load groceries into a vehicle, unload them back at home, and even prepare simple meals in a kitchen designed with structured layouts. Not science fiction, just a logical next step once the robot becomes steady, safe, and precise. The key is environment design. If the world becomes slightly more robot-friendly, robots can do far more. Elon Musk believes humanoid robots will create a world of labor abundance, where physical work becomes optional. And this isn't science fiction. By 2030, the world will have 1.4 billion people over 60. Entire countries are running out of workers. Robots aren't a luxury. They're becoming a necessity. If Tesla truly achieves 1 million robots per year, the global economy changes forever. Optimus Generation 3 is expected in early 2026, and Tesla says it should demonstrate near-human dexterity, precise manipulation, faster walking, and far more autonomy. This is the version that determines everything. If it works, Tesla enters a new category of technology. Not cars, not energy, but physical AI. A machine that can learn any task. Optimus isn't finished. It's not perfect. Some demos were teleoperated, some were exaggerated, some timelines slipped. I'm sure with delays comes frustration. But for the first time, we're seeing the outline of what Tesla is really building. A humanoid that could one day help millions of people. At work, at home, and in places too dangerous, too distant, or too demanding for humans to go. If you found this video interesting and informative, subscribe. I focus on providing valuable, practical and interesting information that can improve people's lives.